As you see here, the green symbols are the batteries. And we know from component testing that we should do everything we can to avoid any kind of exposure of the lithium-ion cells for violence or demolition. And that is why we put them into a hard steel casing into the center of the car and between the rear wheels. That's a very, very important safety philosophy, and we have not compromised it. The batteries are coming from an American company called Lennart, and we will hear Charles later on. And we source them, and they build the batteries up in Indianapolis, and they are supplying us to the final manufacturing in Gothenburg. If you look into another issue, that is the climatization, because you do not have to only climatize your cabin. If you see pictures in the winter time from electrical mobility, they are very good, you know, double gloves and freezing. And they have maybe a small hole in the windscreen. That is not good enough for us. It must be just as comfortable as a normal Volvo vehicle. So we have additional auxiliary heating systems in the car in the winter climate. But there's another issue here. You actually have to develop 3 systems. One is to climatize the battery. Because the lithium-ion battery is like a human person. It's okay between 0, that's at least for a Scandinavian, and up to about 30 degrees, again meaning Scandinavian. And that means that without or outside those boundaries, you have to do something. When it's becoming very cold, then the range of the car is dropping. And also its ability to deliver and receive energy is not okay. Then you have to pre-climatize the battery, and then you will use the grid. As long as you're connected to the grid, you automatically steer this with the programming in the car. Another issue, another cooling system is actually take care of the energy losses you have in the electronics and the motor. The beauty with electrical motors and systems are that they're extremely efficient. This motor has an efficiency ratio of 92 to 94%. It's fantastic. A normal combustion engine delivers maybe 25%. Another issue then is, of course, the climatization of the interior. So it has to be nice and cold when it's like this outside. So of course there's an air conditioning in the car. And it must be very warm and nice when it's very cold outside. And we have an auxiliary heating running on ethanol here to support the system. Very important issue in order for very hot climates is that you are able to cool down the battery. Because that will really have an impact on the longevity of the battery. And we are planning, and we are hoping that we will find the final results now, that this battery will last about 3,000 cycles, and that will actually mean that it has a life expectancy of between 8 to 10 years, and that means that then it will have 80% left of its capacity. That will also call for a good ownership calculation. Electrical safety, very important. There are so many more cables in this car that is hardly imaginable. But the issue here is that we have 3 levels of voltage which you have to take care of. The very important thing is in the event of a crash that you disconnect the battery. So we are using the airbag sensor to disconnect the battery within 50 milliseconds. So when you are actually coming to stop, there is no high voltage available whatsoever. This can also be done manually by rescue staff if they want to have a secondary approach. Another issue is, of course, that we are putting all the high voltage cabling in such a way that when you collide, even in different collision situations, it's harnessed and it's protected, so it will never be cut off or the insulation will never be chafed. Again, electric is a safety thinking. If you look into the charging side, we have in the car an onboard charger, as I said. If it's fully depleted, it takes 8 hours to charge the car. We're looking into fast charging possibilities, maybe in 2 hours. But we are also now looking and talking to UL, Underwriters Laboratory, because we need to understand their thinking on how this should be regulated and steered. So we have a good alignment between the directions and how we have to design the car. Not everything is clear here, so there will be a kind of a continuation of that debate. Very important. Some small issues, electrical handbrake, of course, because there's no space in the tunnel more, it's occupied by the battery. An electrical gear lever that will give you 2 possibilities. The car has, of course, regeneration, and you have that normally when you're lifting the accelerator, you have a full regeneration back into the battery. This is the first level of what we call the HMI, and where you normally have the fuel meter, you now have the state of charge. And on the right side, where it says 0 on the top, that is the meter giving you the indication of how much energy you push into the motor, and when you release the accelerator, when it goes back on the other side, how much energy you actually get back into the battery. So range generation is very important. But that has to be done also with safety in mind, because you have to tune your stability systems. And this is very much negative torque from this motor, which has never been in the car before. So again, full recalibration of the car. Okay. Safety, crash safety, passive safety. There are very, very many good methods in the world to measure safety. There are American methods, European methods, also coming now Chinese methods. The Volvo methods are, of course, those as a base, but on top of that, we are also utilizing our traffic research, which we have been doing since 30 years. We have in our databases 45,000 real crashes, and all the learnings we have from the real life is built into our models. So we are taking consideration of the real outcome of reality in life. And this is also very good input for us. We have designed and we have done a lot of testing. I think up to now we have demolished 12 cars, and it will continue for some time. But we are there now. We are absolutely confident that the car we are delivering is absolutely Volvo standard, which is good. I will now show you some crash sequences, and it's just to give an indication of the kind of violence we have put into the testing here. And the other issue is also, you should know that when we are testing those cars, the batteries are always fully charged. All systems are go, because we want to understand that if something happens in the electrical system, electronic systems, what will happen and how can we take care of it. Very important to crash with live batteries, otherwise it's too easy to run the sequence. So, another thing is, of course, that we have to be connected to the future. So, of course, there are a lot of applets developed now in order to see the range of the car, how it's charging, if it's locked. All these things of conveniences will be there. So, ladies and gentlemen, it's just to plug into the future. Thank you very much.